In the problem number 26, in determination of velocity of sound in air using resonance column tube, radius of cylindrical tube is 1 centimeter and frequency of tuning for 256 Hz. Velocity of sound is given 340. Length of air column in the tube when first resonance occurs is. First, before going to start, I would like to tell you end correction. The end correction you can write 0.6 into r, represented by small e, where small r is the radius of the column, right? And in the resonance tube, antinodes are formed slightly outside the open of the tube. So in first overtone, if I make a simple diagram, then you will see this is the level of water if I take, and as I said, this is end correction, and this is the point of node, and antinode will get here. So this length, if I represent by L1 in the case of first resonance, then the separation between antinode and node is lambda by 4. Lambda is the wavelength, So by this diagram, we can write lambda by 4 in terms of length, and length will be L plus end correction E, right? And we can replace wavelength in terms of speed and frequency. So we'll write V upon N, but 4 is there, and length L1 plus end correction, as I said, 0.6 R. And now the answers are given in centimeter, so you have to be very careful. If I place the value of V is given in meter per second. So I will write 3430 upon 4 into 256. L1 plus 0.6, radius is given 1. So you can see there is one variable that you are going to calculate, and that is L1. So when you will calculate, you will get the value of L1 is 32.6 centimeter. So by this calculation, I can say my option number 3rd will be the right choice. So let's move on question number 27. In the question number 27, the apparent frequency of whistle of engine changes in the ratio 6/5. It's okay. The engine passes a stationary observer, means first engine will go very close to the observer and after that he will pass. If the velocity of the sound is 330, then velocity of the engine will be. So I will write apparent frequency in two ways. When first he will go very close to the stationary observer and will pass. So actual frequency V minus Vs. And in the second case, when he will move far away from this, V plus Vs. And we all know this formula. So if I divide the situation 1 and situation 2, so we'll get F1 upon F2. F will cancel out, V will cancel out. So you have only V plus Vs upon V minus Vs. And that this value is given to the question, that is 6/5. So I can write this is equal to 6/5 because 6 is or 5 ratio are given. So this is the final expression. So when I will calculate, you will take a cross multiplication, will get 5V plus 5Vs, that is equal 6 times of V, 6 times of Vs. Vs means velocity of the source. So first I am going to arrange Vs and Vs. 6 plus 5 means 11 Vs, that is equal V, and Vs is equal to V upon 11, and the value of V, 330 as per the question, 330 divided by 11. So when you will calculate, will get 30 meter per second. So this is the velocity of the engine. So I can say my option number 3rd will be the right choice. So let's move on question number 28. In the question number 28, An observer start moving constant tangential acceleration of 2 meter per second square on a fixed circular track of radius 30 meter. A source kept at the center of the track emits a sound of frequency f0, then apparent frequency heard by the observer. You know that the Doppler effect will get when source and observer will take a relative motion with respect to the medium. But as per the question, this is source and this is observer moving like that, suppose. Before going to take anything, you can see there is no relative motion between source and observer because the separation between them will remain same. On the other hand, you can say the angle between the direction of velocity of the source and observer will be 90. So we can say the apparent frequency will remain f0, means remain constant because there is no relative motion between them. So by this discussion, I can say the option number 2 will be the right choice. So let's move on question number 29. In the problem number 29, the Doppler shift in frequency sound is independent of, but given, source is moving on the straight line joining source and observer. So before going to find the options, I would like to say the Doppler shift in frequency depends on number 1, you know, velocity of sound. Number 2, velocity of source. Number 3, velocity of observer. We know it is independent of the distance between source and observer. So that is the total discussion. So if I use this in our question, then we can say the distance between the source and listener. And question is asking to us the Doppler shift frequency independent of. So the distance between the source and listener, as I said, so that is my final choice. So I can say my option number 1 will be the right choice. So let's move on question number 30. In the problem number 30, the characteristics of sound with the help of which can distinguish between a shrill note and a grave note is. So similarly, this is a theoretical question. I would like to say, if you know, I am going to tell you the main concept. If pitch is high, then sound note will be shrill by the theory. If pitch is low, then sound note will be grave. So that is the fundamental. So if I use this in the question number 30, then we can say option number 2 means pitch will be the right choice. So let's move on question number 31.